Greetings. Welcome to the talk on the elegance of pattern matching in modern Java. My name is Venkat Subramaniam. I'm so delighted that you can join for this particular talk where we're going to talk about an elegant and beautiful feature in Java. Well, pattern matching has been around in other languages for a long time, and over the years I've been really intrigued by pattern matching. It's a feature that actually makes code really elegant and expressive. In all honesty, as I work on different languages, code for production in different systems, when I write the code, I always come back to refactor it just to make it a bit more elegant, more expressive. Part of the reason for doing that is elegant code is easier to understand, easier to maintain. It also reduces the verbosity, and as a result, it reduces the errors in the code as well. And I remember very clearly having to come back to my test cases that are passing and then tweak a code a little bit, maybe to use a bit of a pattern here and a pattern there so that the code can become more concise. And of course, when you come back and look at the code later on, you feel proud about what you have written because it's easier to understand, easier to express. And of course, when you're trying to come back and maintain the code later on, well, the future you, of course, thanks you for writing better quality code. And that's what we're going to focus on today, how we can achieve that in Java to make our code a bit more expressive and elegant as well. So what in the world is pattern matching? Don't confuse this with regular expressions. That's been around for a long time as well, but this is not about actually using regular expressions, but to really match the data that you receive against different patterns of types and values, if you will. That's what we are really after. Let's take a look at what are the benefits first of all, then we'll dive in and look at the features. Well, the number one benefit really is your code size simply shrinks. You don't have to write all those verbose set of if and else statements and those, walking through 70, 80 lines of code and forgetting what you're there for in the first place. So your code becomes really concise and expressive, and in a way that data flows through as you get the data depending on the type or the value, you take actions or perform computations, it becomes really expressive. The places where I've really benefited from this are where I have an algorithm or a logic that's got to do different things based on the different types of values that I receive. As it turns out, that happens quite often in a lot of computations. For example, from the business point of view, depending on the type of the credit card or type of the transaction or the nature of the user or their subscription level and so on. Well, let's take a look at an example of how we can do this, but let's step back a little bit to look at one thing that's been in Java for a few different versions, which is a pattern matching for instance of. This is going to show us the benefit of using the pattern matching in the if, and then we'll just grow into a pattern matching after that along the way. Let's start with a little example to work with. Let's say we're going to output the result of a call to a process function. We'll call with a 1, but let's also call the same function with, let's say, a hello. So consider this to be some message you are receiving, maybe from a messaging system, and you want to process the messages as they arrive. So how do we really deal with that in your application? Well, here's what we did in the past. You could write, for example, a function that's going to return a string. We'll call it as a process function that receives some kind of an object. We'll call it input like so. Well, in this case, we want to say if the input is an instance of maybe an integer, then we want to take a certain action like so. Of course, if it's not an integer, what do we want to do? Well, we could say if the input is an instance of, let's say, instance of, in this case, let's say a string, we want to maybe perform a different action. And if it's not either one of them, maybe we'll simply return no clue to say we don't have a clue what we are dealing with. So in this particular example, of course, we have a public static method which is going to take a string or return a string rather. So we can see it's a no clue for both of those. But of course, we want to do some special operation for integer. So we could return, for example, got an integer, and maybe I'll simply return in this case the value that we received, maybe input. Hey, that was really easy, wasn't it? But what about string? Well, for the string, we may be tempted to say a return maybe got a string of length. But how do I know what the length of the string is? So we could say stir.length, But what in the world is stir? Well, obviously in this case, we could say string stir is equal to, and of course, I'm going to say the input given to us. Of course, the compiler would not like it because we got to cast the string or the object reference given to us. So we do the casting like so oftentimes. That makes for a verbose code, as you know, as you're writing this particular code, that can become really not so expressive, not so elegant. Wouldn't it be nice if we can really pattern match into it along the way? Well, that's exactly what you can do. You can go back to this code and say, hey, if the input is of type of string, just give me a variable called stir right now, which is going to hold on to that particular reference, but with the type string. So you can execute that code right there and get a result where the length is string. Well, this is like the origin of the pattern matching syntax, but it blossomed into something absolutely elegant in more versions of Java since the time this was introduced. So this is where we can perform a type matching or a type pattern matching, if you will. Look at the code we wrote. We already see the benefit, but wouldn't it be nice to have it a lot more elegant than this? Well, with the introduction of switch expression, you can use pattern matching with both switch expressions and the switch statements as well. Let's turn this into a more elegant code, if you will. So switch input, and I'm going to simply write that as a switch expression. We're going to get rid of these parts in just a few minutes. But here we're going to say case, and in this case, I'm going to say if the value is an integer that we are receiving some integer I'm going to simply return from here, well, got an integer, let's say in this case, a plus the value I we received. On the other hand, if it's a string, let's say stir like we did, we can say got a string right there of length. And in this case, of course, we can say stir.length and call that method. And of course, if it's not either one of them, we can say default and say no clue like we did a few minutes ago. So in this case, we can remove all that verbosity from that code and we can see how elegant that one is. So if the given input is an integer, take this action and return this result of this expression. If it's a string, take this action, return the result of this expression. But if it's neither one of them, return the no clue text, as you can see. So this becomes a nice syntax here, as you can see. In this case, you say the type and a variable of that reference, and of course a type again and a variable stir of the reference type string, where str is the same instance as the input given, just a different type for the reference. So it becomes easier for us to avoid that typecasting mess and write this code really nicely, more elegantly. So you saw the pattern matching for a type of the variable or the reference that you received. But of course, one gnarly issue we often have to deal with in code. I know nobody here likes to deal with it, but that's life in the big city. We have to deal with it, unfortunately, which is a null in the data that we are receiving. So imagine for a minute that rather than having a one and hello like this, what if you really had a list of, let's say, or let's say in this case, an arrays, let's say as list. And in this, we have a one and hello. And you want to be able to take this and say, for example, let's say dot stream, and we will do a for each. And what do we want to do with this for each? We want to take the data and maybe print it out. So we'll say system.out, and we will just print it out right there. But what do we want to print out? Well, not just the data one and hello, obviously, but the transformed data. So we could say, for example, a sample, and we could call upon the process function to perform the transformation of the data really nicely. Well, that all looks great so far until on that fateful day, we are receiving a null as a value. Well, what do? Well, you can see we got a boom null pointer exception, which is not very pleasant. So traditionally in Java, if a switch is given an expression which turns to be null, it blows up. Well, that's not really elegant. So what do we do normally? We come pretty defensive when we write the code. And unfortunately, we will have to say, if, for example, input is equal to null, we want to take some action. But how sad that is, because we got to write some extra code to handle it. Well, yes, traditionally, Java switch statement blows up on a null, and it still does if we don't handle null. However, we can make this really elegant. We can say if it is a null, maybe what I want to return is, we can say friends, maybe we'll say friends don't mess with null, or friends don't let the friends, if you will, mess with null, right? So we could specify that maybe as a value we want to return if the value were a null. So you can see in the output it says friends don't let friends mess with null. So that's basically a nice and elegant way to handle the null if the data that we receive happens to have a null in it. Well, so even though the traditional code blows up on null, we can in modern Java pattern match for null. How cool that is. Definitely, of course, I'm not encouraging we to deal with more nulls in this case, but if we have to deal with it, at least we don't have to have the pain of dealing with it. This makes it a lot more elegant. Well, of course, if you really want to handle that alongside of handling maybe something else, you can certainly do that as well. So for example, in this particular case, you could say you can say null r, maybe an integer I, and then what do I want to do? Maybe we'll combine those two together in this particular case and handle it. So what is I in this particular case? It says got an integer I, as you can see, of course, integer it said. So let's fix that really quickly. Integer I, or it says got an integer null. So we kind of decided to group them together and handle them as the case may be. So you don't have to handle it separately. You could handle it as part of something else, maybe that'll handle the null as well, and you can combine them together if you really wanted to. Well, so we can see the beauty of the syntax. It's elegant, it's concise, it's easier to write. And of course, when such things happen, one of the questions we often ask is, what if? Well, the answer is not clear cut. It depends on the language. It depends on the library that you are working with. So when you deal with pattern matching across multiple languages, it's a good idea to take the time to understand the semantics and how the language deals with when there are multiple possible matches, what's going to happen. Well, in the case of Java, in a lot of other languages, the first one is going to win. Now, you could say, wait a minute though, but doesn't Java have dominance? Sure, it does. But if there's a situation where clearly the compiler cannot determine the dominance, then the first one is going to win. So think of a pattern matcher like a coin sorter. If I take multiple coins and put that in a coin sorter, well, the best fit is going to come through first, and then the left of the things are going to go through other sorters. So the first one always win. So if think of these as multiple doorways, and if you can enter through the first door, you're going to enter it, even though the second door may be appropriate. But of course, for the sake of reducing errors, where possible, Java compiler will determine the dominance for us and give us an error where clearly there is a conflict between the cases, and it's possible that one case is covered entirely and so may be hidden by a case above. So in other words, from the dominance point of view, we can see the benefit in here. So let's take a look at an example of this right now. So suppose we were to write an example where we said if it is a number, we'll say it's a number n. We'll say got a number, and we will say the number n that we received. So going back to this example, we could say 3.2 over here. And when we execute the code, let's see what we're going to see in this particular example. Well, obviously, I need to be paying attention to what I'm writing. So let's go back and run the code again. So what's going to happen? Well, of course, null pointer again. We'll get rid of the null since we know how to handle that. Let's try to not deal with nulls right now. So when we execute the code, you can see got a number 3.2. Hey, that's great. That works with one was handled by the first case. The hello was handled by the third case, and the 3.2 was handled by the second case, as you can see right in here. And just for the sake of completeness over here, suppose I were to say over here, oh, what else can I bring in? Maybe I want to simply say a true for a Boolean value, and you can say no clue is the result that's handled by the fourth door, so to say, in here. But of course, in this example, 1 is an integer, so it went through here, but 3.2 is a double, and that went through the number, as you can see, and that's why it says got a number 3.2. However, if you were to flip these two around, what's going to happen? Well, the compiler clearly notices that the number is going to deal with all numbers, including integer. So unfortunately, that is wasted. That is being hidden, that's being shadowed, and it would never get the chance ever to be executed. That's kind of like putting code after a return expression, if you will. A reasonable compiler will give you an error, isn't it? So for example, we have a return here, and if I said, here in this particular case, the compiler is going to give you an error saying unreachable statement, as you can see at the very end. Well, that's exactly the problem we're going to run in here, because this one right now is unreachable for a given number, because all numbers are going to exit right there, and it's never going to get here. And how sad if the compiler kind of looks at it and shrugs its shoulder and says, I hope you know what you're doing. It's a genuine mistake we all make, and it's nice to have a friend like a compiler that politely tells us, dude, did you really mean that? Go back and take a look at it. So when I run the code right now, well, actually the compiler stops me and says, error, this case label is dominated by preceding case label. What a beautiful error message, isn't it? This case label is dominated by the preceding case label, and that's in Java line number 7, you can see, and that's line number 7 right there, and it's giving you an error. If you were to move that down further down, you can see again it says by a preceding case label. Again, the error is on line number 8 right now to say that, hey, this is not going to be executed because of the number. And of course, if I were to move it around, the error goes away. So that's basically about dominance. But of course, if you are dealing with multiple, scenarios where you may not know exactly which one you're dealing with, it's possible that you may slip around, but generally Java compiler is there for you to protect you. And if it determines that clearly that this cannot really be possible to execute because of the other one, it'll tell you that there's a problem of dominance and will complain, and so you can handle that very nicely. Now, I kind of alluded to the fact that sometimes a compiler may not really be able to determine the dominance, and that, for example, is maybe you're trying to match against an interface you are implementing, and maybe there are 2 or 3 interfaces you're checking for, and it's possible that you may go through one and not the other because a class is implementing multiple interfaces. Now, in that case, it's not maybe entirely an issue of dominance. Maybe that all of them are candidates at the equal footing, but maybe you'll go through one for a particular class always compared to another, and in all fairness, there is no clear dominance to be determined, so the compiler may not give you an error at that point. But in general, though, when there's a clear way that a particular expression will never be executed, then the compiler will give you an error to say that you are hiding that particular expression. It's never going to be taken. Why bother writing it? That's probably an error, and it's going to give you an error. So that's basically about dominance, and that's being implemented. Well, that's great, but I want to talk about 2 more things before we wrap this up. One is about completeness. And I'm a big fan of, again, compilers that are smart enough to look over our shoulder so it minimizes the chances of errors for us. So going back to this code right here, what if I leave out the default? Notice that I get an error saying the switch expression does not cover all possible input values, and it gave me an error. So the default is required in this particular case, because if I don't put the default and if if the value comes in that doesn't enter any of these doors, if it doesn't match with any of those doors, what do? Well, I want to know that I've made a mistake. I don't want a runtime failure where something goes wrong. It's better to know it at compile time. So that's exactly what you see here is the compiler telling you that all possible paths need to be covered. Now, of course, you don't have to put default all the time. For example, one such situation is when the compiler can determine clearly that all paths are actually covered and a default is actually redundant in that case. Let's take a look at an example. Suppose I come up with a sealed interface right there, and let's say this is a sealed interface called, let's say, a time of day, I'm going to say, and the time of day interface, I'm going to say final class, let's say daytime, which implements, let's say, the time of day, and I'm also going to provide a nighttime as well, which are the two different classes that I'm implementing in this particular case. Well, I'm going to go back to this code, and in the process, I'm going to say, rather than the object, I'm going to say time of day, which I'm going to receive as an input, and I'm going to say, in this particular case, deal with those two situations or scenarios. So let's go ahead and call the process function, and in this case, we will say a new daytime, and I'm going to also call that with maybe a new nighttime as well. Well, now let's go back to this code and say case, and I'm going to say daytime, and what am I going to do with the daytime? I'm going to simply say maybe bright, and as it is really bright, depending on where you are in time of the year, of course, but let's say in general, the daytime is really bright, and I'm going to say here comes the nighttime, and I'm going to say dark. Again, depends on the time of the year. If you're in some part of the world, you have brightness throughout the nighttime as well. So hypothetically speaking, we could write a code like this. But notice it did not complain that we don't have a default. And the reason is because that's covered by the values that are possible. If I say no clue over here, yes, I'm having no clue as a programmer, that is not really required at all. Now, of course, one question you may ask is, what if we don't put the default? By the way, I highly encourage you not to put the default. And if you don't put the default, and what if in the future you were to modify your sealed class hierarchy and this part of the code has been compiled in a separate file? What gives? Well, here comes the charm. If you look at the bytecode being generated, Java actually inserts a default right there for you, where the default will blow up if it's one of these two values, which is brilliant, by the way, because if in the future, if you were to modify the sealed hierarchy, rightfully you want to get an error rather than handling a default value that you didn't intend to. So my recommendation is don't put the default unless the compiler insists for you, and then of course rely upon the compiler helping you, and you can rely upon if you add a new type during testing, is going to be really revealed very quickly, and you can be safe about it rather than handling it in a way you did not really expect it to be, and that is something you want to do. So if you change in the future, you are still covered. That's the good news. Well, that brings us to almost to the end of this, but I want to give you one more example before we call this done. So let's go ahead and create one more thing here, a process function that's going to take a vehicle that's going to come in as an input. And I'm going to say I have a car and I have a truck here that I want to work with in the case of a process. Let's go ahead and say return an empty string right now. So we have a class called vehicle that we created. We have a class called car that extends, let's say, a vehicle, and we have a truck that extends a vehicle as well. We'll start with those steps to begin with. But what I would like to do right now is I want to process here, but before we go, let's say for the class car, we have one more option. We'll say Boolean, let's call this as electric, as we all fancy these days, and we will say public car, and we'll say Boolean electric, and we will say in this particular case, this dot electric, let's say, is equal to electric, and let's go ahead and provide one method right here, a Boolean is electric, let's say, that I want to simply say a return, in this case, electric. So that's good enough for our purpose right now. So in this particular case, we have a constructor for the car. So let's go ahead and create a truck to begin with, and a car where the first one is not an electric car, the second one is an electric car. Now, given this particular situation, I want to take action based on certain conditions. So in here, we could say return a switch on an input. And what do I want to do with this particular switch? Well, the case is a truck, let's say. I'm going to simply return, a fuel up, let's say. That's all I'm going to return if it were a truck. And I'm going to say a default, and I'm going to say, I don't know what to do in here. I'll simply say whatever for now. So you can see in this particular case, we are returning, if the case where a truck object will say truck, we want to return a fuel up. On the other hand, if it's not a truck, we're returning whatever. Well, if it's a case is a car, what do I want to do? So I'm going to decide on what to do if it were a car. But of course, I don't want to fuel up or fill up. So if I were to say fill up, that's not going to end really well for an electric car. That's going to be really messy. Hey, what's the point of getting an electric car if you're going to fill up like you normally do? So in this case, of course, you may be tempted to write a messy code where you check if it's an electric car, if it's not. My goodness, that's smelly again. We don't want to be writing such smelly code. There's got to be a better way to write that code, isn't it? And thankfully, Java has us covered. So you can say if it's a car in general, we can say fill up. So that's basically what we're going to do for a car. But of course, we don't want to fill up an electric car. So what do? We say if it's a car and if the car is electric, then of course, very proudly, let's go ahead and charge rather than fill up. And we can write the code like so. So you can see the fuel up for the truck, a fill up for a car in general. But if it's an electric car, it did a charge for us and returned it as well. And of course, you got to agree that's pretty darn elegant. So those are called guarded pattern matching, where you apply a guard saying don't go this path unless you meet that extra condition as well. So if it's a truck, it's going to go through this one. If it's a car, it's going to go through that one, but only if it's an electric car. Otherwise, it's going to go through here and handle it. Of course, you're probably thinking, hey, but with the guard, what if I put them in a wrong order? You know the answer to that already. The dominance kicks in. So if you remove that into this other sequence, well, all cars are going to go through that, and you're going to end up filling up an electric car, which is really bad. But of course, it's not the reason why the error is going to arise. It's because this part is not going to be executed for any car because it's going to go through that part, and you better get a compilation error. And so you did. It says the case label is dominated by the preceding case label, as you can see, and so the compiler again is watching out, so you never put gasoline on your electric car, so to say. But of course, it's the question of dominance that's being verified in this particular case. So this is basically where we look at the power of pattern matching. But the better news is it's already good, but it's going to get only better as we move towards this in the future. Well, one of the beautiful things about pattern matching is now that we know how to pattern match and work with guarded pattern match, it's a question of time before we start extracting data, a concept of destructuring or deconstruction that can be nicely merged with pattern matching. And that absolutely is going to blow our mind, because not only can we pattern match based on different types, not only can we use a guarded pattern matching based on certain property values, but we can also extract those values as we are processing the pattern. So stay tuned for the versions of Java ahead for those elegance. But in the meantime, start benefiting from what Java has already given us, and exciting times for us programming in Java. The language is evolving, and we are able to make use of these wonderful features and a lot more as well. So I hope you will be able to apply pattern matching to your own projects very soon. So enjoy and have fun.